So this is the continuation part of squares and square root. In the last part we discussed about squares. In the last part we discussed about squares. So now we are discussing about square roots. So now we are discussing about square roots. So square root. So finding the square root is the inverse operation of squaring. So it is the inverse operation of squaring. The finding the square root is the inverse operation of squaring. So that is, you know that 3 square is 9. What is the meaning of 3 square? So that is 3 into 3. So 3 3 is 9. So 3 square you get 9. So therefore, the square root of 9. So that is the inverse operation of squaring. So square root of 9 is 3. So you go backwards. So square root of 9 is 3. So you write like that, the square root sign. So you call it as this is the square root. Okay. Square root of 9 is equal to 3. So there are two integral square root of a number. There are two types. There are two numbers. There are two integral square root of a number. So that is square root of 9 is 3 and minus 3. The square root of 9 is 3 and minus 3. You see that? So 9 can be written as 3 into 3. So 9 can be written as 3 into 3. So there is one more method. So minus 3 into minus 3 is also 9. So 3 3 is 9. Minus into minus become plus. So therefore you have two roots. One is 3 and one is minus 3. So there are two integral square root of a number. So that is square root of 9 is plus 3 or minus 3. Plus 3 and minus 3. So if you take 4, so you get plus 4 minus 4 like this. So in that lesson we are discussing about only positive roots. We are discussing about only positive roots. You not consider negative. So you have to neglect negative in that lesson. So you consider only positive roots. So next you go to squares and square roots. You see that. So I written several squares and square roots. So the first column represents square roots. The next one is square roots. Okay, see that. 1 square is 1. So 1 square is 1. So square root of 1 is 1. So that is the reverse operation of squaring. So square root is the reverse operation of squaring. So root 1 is 1. So 2 square you know that. So that is 4. 2 square equal to 4. So the root of 4 or square root of 4 is 2. The square root of 4 is 2. Similarly, root 3 square you get 9. 3 square 9. So root 9 is equal to 3. Root 9 is equal to 3. So next 4 square equal to 16. 4 square means 4 into 4 16. So root 16 means 4. Root 16 equal to 4. So next 5 square is equal to 25. 5 square is equal to 25. Therefore root 25 is equal to 5. So similarly, you have 6 square, 36, that means 6 into 6, 36. Therefore square root of 36 is 6. Square root of 36 is 6. 7 square equal to 49. So square root of 49 is equal to 7. Square root of 49 is equal to 7. 8 square is equal to 64. So 8 square, you know that is 8 into 8. So that is 64. Therefore root 64 is equal to 8. So 9 square is equal to 81. So that means 9 into 9 you get 81. So root 81 is equal to 9. So finally 10 square is equal to 100. Therefore root 100 is equal to 10. So now finding the square root through prime factorization. So finding the square root through prime factorization. You know that. So what is the prime number? So prime number is a number. It has only two factors. One and the number itself. Suppose I take 2, 3, 5, 7. So these are all prime numbers. 4, 6, 8. So these are all composite numbers. You see that? So 2, it has only two factors, 2 and 1. So I consider if it is 4, it has 3 factors. One is 2. 4 can be done as 2 into 2 and 4 into 1. So total it has 3 factors. So these are all prime numbers. Why? It has only 2 factors, that is 1 and the number itself. So you call it as prime numbers. So this is composite numbers. So now you concentrate about prime numbers. So finding the square root through prime factorization. So that means you take all, you divide 256 using prime number. So first smallest prime number is 2. So you divide it with 2. You see here. 2 ones are 2, 2 twos are 4. So 2 twos are 4 means 1 remainder 16, 2 eights are 16. So next 2 6 are 12, 2 6 are 12, 2 4s are 8. So next 2 3s are 6, 2 2s are 4. So next 2 1s are 2. So 1 carry, 2 1s are 2, 1 remainder 12. So 2 6 are 12, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. So you have 1 2 3 4 5 6 7 8 2s. So now 256 is equal to, so 2 into 2 into 2 into 2 into 2 into 2, 1 2 3 4 5 6 7 8 times. Okay. So now root 256. So make it a pair. So 1 pair, 2 pair, 3 pair, 4th one. So is equal to, right now only once. So 2 into 2 into 2 into 2. So that means 2 2s are 4. So 4 into 4, 2 2s are 4. So 4 4s are 16. Therefore, the square root of 256 is equal to 16. Therefore, the square root of 256 is equal to 16. That means 16 square is equal to 256. 16 square is equal to 256. So next question. So 7744. So find the square root of 7744 using prime factorization method. So first you do that prime factorization. So you go through 2 3 is a 6. You take 1. Carry 17, 2 8s are 16, 1 carry, 7 is are 14, 2 7s are 14, 2 2s are 4. So next one more time 2. So 2 1s are 2. So 1 remainder 18, 2 9s are 18, 2 3s are 6, 1 remainder 12, 2 6 are 12. So next one more time 2. So 2 9s are 18. So 1 remainder 13, 2 6 are 12, so 1 remainder 16, 2 8s are 16. So next 2 4s are 8, 1 remainder, so that is 16, 2 8s are 16, 2 4s are 8. So next 2 2s are 4, 2 4s are 8, 2 2s are 4. So next 2 1s are 2 2s are 4. 2 1s are. So now it is 11. So 11, 11s are 121. So 11 1s are. Okay. Therefore 7744 is equal to 2 into 2 into 2 into. So 1 2 3 4 5 6 times. So right here 11 into 11. Okay. So now square root of 7744 equal to, so now make it a pair. Okay. So you consider only one. Okay. So this is 4 into 22. 4 2s are 88. So 4 into 22 you get 88. Therefore, the square root of 7744 is equal to 88. So next problem, 15,876. So you have to find the square root of 15,876 using prime factorization method. So first you go through prime factorization. 2 7s are 14. So 1 remainder 18. 2 9s are 18. Okay, 7. 2 3s are 6. 1 remainder 16. 2 8s are. Okay, next 2 3s are 6. So 1 remainder 19. 2 9s are 18. 1 remainder 13. 2 6s are 12. So 1 remainder 18. 2 9s are. So next you go through 3 table because it is odd. And you see that if you add 39, 3 plus 9, 12, 12 plus 6, 18, 18 plus 9, 27. 27 is divisible by 3. Therefore, the whole big number 3969 is also divisible by 3. So now you have to divide it by 3. 3 ones are 3, 3 threes are 9, 3 twos are 6, 3 threes are 9. So one more time 3, 3 fours are 12, 3 fours are 12, 1 reminder 12, 3 fours are 12, okay, 3 ones are. So now it is 441. So now one more time, 4 plus 4, 8 plus 1, 9. So 9 is also divisible by 3. Therefore 441 is also divisible by 3. 3 ones are 3, 14, 3 fours are 12. So 1 carry, it is 11. Okay, it is 2 reminder, 21, 3 sevens are 21. So next one more time, 3 fours are 12, 2 reminder, okay, it is 27, 3 nines are. So now 49 is divisible by 7, 7 ones are. So here, so 1, 5, 8, 7, 6 can be written as 2 into 2, 3 into 3 into 3 into 3, 4 times 1, 2, 3, 4. So into 7 into 7. So make it a pair. So find the square root of 15,876 is equal to, so make it a pair. Okay, so you write ones now, 2, 3, 3 into 7. So that is 2 3s are 6, 20, 3, 7 3s are 21. So that is equal to 6, 6 2s are 12. So 126. Therefore, the square root of 15,876 is equal to 126. That means 126 into 126 you get 15,876. So for each of the following numbers, so find the smallest number by which it should be multiplied so as to get a perfect square number. So also find the square root of the square number so obtain. So what we are obtaining? So what they given, it is not a square. So what they given 4851 or 968, that is not a square number. So you make it square by multiplying the smallest number. So we have to multiply smallest number so that it will become a perfect square number. And also find the square root of that perfect square. So also find the square root of that perfect square. So first 4851. So this is the 4851. So we have to do that prime factorization. You get. So first you go through 3 table. 3 ones are 3. So 1 carry or 1 reminder. 18. 3 6 are 18. 3 ones are 3. 2 reminder. 21. 3 sevens are 21. So 3 5s are 15. 1 reminder 11. 3 3s are 9. 2 reminder 27. 3 9s are 27. Okay, next you go through 7. So 7s are 49. 4 reminder 49. So 7 sevens are 49. Okay, now it is 77. 7 11s are 77 and 11 ones are 11. Okay, next. So now 4851. So can you write as the factors in terms of product of factors? 3 into 3, 7 into 7 into 11. So 3 into 3 into 7 into 7 into 11. So now to make 4851 a perfect square, it must be multiplied by 11. Since you know that, so all the numbers we have two numbers, 3 into 3, 7 into 7, but 11 is not paired, so you want one more 11. Therefore, to make 4851 as a perfect square, it must be multiplied by 11. So that is, you get a new number, 4851 into 11. So you multiply to 4851 into 11. So that is, you get 53,361. So 53,361. So that is the next square number. That is the next square number. So that can be written as 3 into 3, 7 into 7 into 11 into 11. So you have 211 now here. So therefore, the square root of 53,361 is equal to, so one time you take 3 into 7 into 11. So that you get 3 sevens are 21. 21 into 11, 231. So now the next problem 968. The next problem 968. So go through prime factorization. 2 4s are 8. 1 reminder 16 it is now. So 2 8s are 16. 2 4s are 8. Okay, next 2 2s are 4. 2 4s are 8. 2 2s are 4. So next 2 1s are 2. 2 2s are 4 and 2 1s are 2. So 121 is a factor having 11. 11 11s are 121 and 11 1s are 11. Therefore 968 can be written as in terms of product of prime factors, that is 2 into 2 into 2 into 11 into 11. So to make 968 a perfect square, it must be multiplied by 2 because all the numbers will have a pair 2 into 2 and 11 into 11 and 2 you have one pair. So if you make it pair, you have to multiply it by 2. Therefore you get a new number, that is 968 into 2. So that is 1936. 1936 can be written as 2 into 2, 2 into 2 into 11 into 11. So now you take the square root of 1936, that is 2 into 2 into 11, that is 44. Okay, next type of problems. For each of the following numbers, find the smallest number by which it should be divided so as to get a perfect square number. Also find the square root of the square numbers over time. Okay, so you have 768. You have the 768 number. So that is not a perfect square. It is not a perfect square. So you have to make it perfect by dividing some smallest number. We have to divide the smallest number so that it becomes perfect number and find the square root of that perfect number. Okay, so first one 768. So find the prime factorization of 768. 2 3 is a 6. One reminder, it becomes 16. 2 8 is 16. 2 4 is 8. So now 2 1s are 2. So one reminder, now it is 18. 2 9s are 18. 2 2s are 4. So now 2 9s are 18. One reminder, that becomes 12. So 2 6s are 12. So now 2 4s are 8. So that becomes 16 now. So 2 8s are 16. 2 2s are 4. 2 4s are 8. 2 1s are 2. 2 2s are 4. 2 6s are 12. 2 3s are 6. 3 1s are 3. So therefore 768 can be written as in terms of prime factorization or the product of primes. So these are all numbers what you call it as primes. 2 into 2 into 2 into 2. So how many times you see that? 1, 2, 3, 4, 5, 6, 7, 8 times into 3. So 2 into 2 into 2, 8 times into 3. To make 768 a perfect square, it must be divided. So we have to remove these 3. So now it will become a pair. 1 pair, 2 pair, 3 pair and 4 pair. So 3 is unpaired. So we have to remove. So we have to remove by dividing 3. So divided by 3. So therefore a new number 768 divided by 3, you get 256. 3 1s are 3 2s are 6. One reminder, now it is 16. 3 5s are 15. One reminder 18. 3 6s are 18. Okay. So 256 can be written as 2 into 2 2 into 2 8 times. So you have to remove 3 there. So now you remove 3. So that means you have to divide it by 3. Therefore, the square root of 256 is equal to, so 1, you write 1 times, 2 into 2, 2, 2 into 2 into 2. So that becomes 4 into 4, so 16. Therefore, square root of 256 is equal to 16. That means 16 into 16 you get 256. Okay, next problem. 36,125. 36,125. So prime factorization now, you see that. So the last number 5, so it is cannot divisible by 2 or 3, you go through 5. So 5 7s are 35. One reminder, now it is 11. So okay, 11. 5 2s are 10. So one reminder, now it is 12. So 5 2s are 10. Okay, 2 reminder, now it becomes 25. So 5 5s is 25. So next, 5 1s are 5, 2 reminder 22. So 5 4s are 20, 2 reminder 22. 5 fours are 20, 2 remainder 25. So 5 fives are 25. So next 5 twos are 10. So 4 remainder 44. So that means 5 eights are 40. 4 remainder 45. So that 5 nines are 45. So now it is 289. So this is divisible by 17. So 17 17s are 289. So 17 ones are. So 36,125 can be done as 5 into 5 into 5 into 17 into 17. So to make 36,125 to make a perfect square, it must be divided by 5. So we have to remove this 5 by dividing 5. So you get a new number, that is 36,125 divided by 5. You get, so if you divide it by 5, you get 7,225. So you get 7,225 equal to, so 5 into 5, 17 into 17. So now the square root of 7,225, you get, so 5 into 17. So that is equal to 85. Therefore, the square root of 7,225 is equal to 85. Or 85 square, you get 7,225.